two consecutive odd integers have a product of 99. Find all sets of integers that fit this description. So I guess the thing that you have to think about is first, what is a consecutive odd integer? Can you give me an example of a consecutive odd integer?
1, 3.
1 and 3. 9 and 11. 17 and
15.
well, 15 or 7 and 17 or 17 and 19. Okay, so if you have a consecutive odd integer, and if you call the first number as x, what's the next number?
X plus 2.
X plus 2. So those are the two numbers, right? And that's something that you should keep in mind when you solve equations like this. If you have a word problem that says consecutive odd integers or consecutive even integers, then these are 2 apart. Okay? If you have a word problem that says just consecutive integers, then if the first number is x, then the next one will be x plus 1, right? So those are the things that you have to keep in mind for these word problems. And then the next thing is, it says a product. Oh, that's nice. It's asking us to multiply them. So I'm going to multiply it. X and x plus 2 are multiplied. And it should have a product of 99. So what does that mean?
Equals 9.
It has to equal to 99, right? So you should be able to read this and say, oh, okay, so I'm looking for 2 integers that are 2 apart, which if you multiply, you end up with 99. Okay? And then there's this cryptic question at the end. It says, find all sets of integers that fit this description. Okay. So apparently, it seems to suggest that there's more than one. Yeah. Maybe or maybe not. So let's see what it means. Okay. So let's try to solve this. We multiply. This is x squared plus 2x equal to 99. Subtract 99, and you get x squared plus 2x minus 99. So you have a quadratic equation, and it will be easier to factor if you know, it will be easier to solve if you know how to factor, right? So I'm looking for 2 numbers that multiply to negative 99 and add to positive 2. What are those 2 numbers? Yes?
11 and negative 9.
Yes, 11 and negative 9. So if you have 11 times negative 9, it does give you negative 99. And if you add them, what do you get? You get 2. So 11 and negative 9 are the 2 numbers. And we all know that if you find those numbers, then you can factor the quadratic as x plus 11, x minus 9 equal to 0. Okay, now let's solve it. When you have 2 products equal to 0, that means at least one of them is 0. It's either x plus 11 equal to 0 or x minus 9 equal to 0. When is x plus 11 equal to 0? Well, if you subtract 11 both sides, you get x equals negative 11. What about this? If you add 9 both sides, you get x equal to 9. Okay. Now, it's very easy to just stop here and say, oh, these are the answers. But it's not. What's the question asking for?
All the sets of integers.
Yeah, it's a set of integers. What's a set? It's a collection, right? So you have to say both odd numbers, okay? So let's start with this one because it's positive and it's easier to think. Okay. So if x is 9, what's x plus 2? 11. So this seems to suggest that the 2 consecutive numbers are 9 and 11. Let's see, is it true that if you multiply them, you get 99? 9 times 11 is 99, right? So that does work. So that's a check. Now let's go over here. Does this mean anything? Well, first of all, is negative 11 an integer? Yes or no? Yes, it is an integer, right? So natural numbers are 1, 2, 3, 4, 5, and so on, so on, so on. whole numbers, you just add 0 to that list. And when you have integers, you're allowing negative numbers too. So negative 11 is indeed an integer, and it's an odd integer because 11 is odd, okay? So if x is negative 11, let's think about what x plus 2 is. What's x plus 2? What's 2 added to negative 11?
Negative 9.
Negative 9. Now, multiply these two. Negative times negative is positive. 11 times 9 is 99. So you do get 99, right? Okay? So we see that this is, again, another set that does work. So we can finally write down the solution as follows. We can say 9 and 11. And then also negative 11 and negative 9. These are the two possible solutions to this question.